Okay, so first of all, my name's Seth. I'm here to talk about continuous integration and deployment, which is uh, often referred to as like DevOps or pipelines or automation. Um, but just the overall point of this is how do you get machines to do stuff that are annoying tasks that you don't want to have to redo all the time? So, first of all, though, I'll give a bit of background on myself. I'm a software engineer who I guess doesn't know how to smile in photos, as you can see here. But by day, I work at a sports broadcasting company on graphics, and by night, I work on my own game called IsoMetro, and there's other people also working on it. It's not just me, for sure. My favorite language is Rust. Believe it or not, I actually don't really love dealing with shell scripts or uh, DevOps pipeline stuff if I don't need to. So hopefully by still giving this talk and showing the importance, I can kind of uh, explain that this is definitely something that's worth getting into, even if you don't like uh, having to deal with these sorts of things all the time. Um, so yeah, I mean, what is the whole point of CI and CD, continuous integration and continuous deployment? The whole point is we forget things. So we forget to test our code. We forget to run commands and tools that will clean up formatting. We forget to run tools that might be specific to our project that, maybe aren't in other projects. Kind of just forget they're there. We forget to deploy our tools, our games onto stores or elsewhere. We forget to generate documentation, even when there are tools that will do that for us if we just run the dang command. There are plenty of ways that we might want to notify our other developers or notify the general public of new updates to things, and we just forget to do that. And lastly, we forget to do all this in a clean and consistent environment. So we forget, to wipe out stale files where we're doing builds, or we'll forget to package things in the same exact way for every update. And these can all lead to headaches. Aside from the time you spend having to remember to do these things, if you don't do them just right every time, you can cause a disaster. So the nice thing about CI and CD pipelines is they don't forget. Now, if you don't implement them properly, you could have situations where they don't work, but at least, you can see something failed to run and you can go and figure out what you need to do for a specific thing, and then everything else is still good. Um, so some products that implement CI and CD sort of practices include GitLab, which is my favorite. Basically, GitLab is a place where you can upload your code, and then whenever you push, GitLab also will have the capability to run tasks that you've defined, just see in the same platform. GitHub, very similar story. And then there's other softwares like Jenkins, Travis, and CircleCI, and tons of others. These are just pulled from kind of just random example. I don't really even use these. I had to use Jenkins at one point in the past. Well, several points. Repressed memories. I don't like Jenkins, but it's still a thing. Um, and the point of these is that with them, you don't necessarily have to have your CI/CD pipelines built into the product where you're pushing code. These third parties will, have the capability to like watch a code base. You just need to set up credentials and stuff, and they'll kick off pipelines when they've noticed something has changed. Um, as far as when to automate things, I mean, I kind of want to get this out of the way first because people will think that I am advocating that we should put absolutely everything into a CI pipeline for like a Hello World project. I don't believe in that. It's more, once you get up to scale, you need to recognize that there are benefits uh, when you look at everything sensibly. So you can automate lots of things. It doesn't make sense to automate everything unless you can actually identify um, a value that you're going to get out of that automation, because it does take up time to engineer those automations. Granted, there's a lot of stuff nowadays you can just kind of get quote unquote out of the box. There's Docker images you can pull down and just use. There's plenty of command line tools you can install through like Python, just Rust ecosystem libraries, just plenty of stuff. Um, but still, even then, adding new automations, if you have limited compute time, like let's say you're paying for AWS instances that run your pipelines, um, you can have costs add up. Or let's say you have a GitLab runner in your house, like I do, because it's a lot cheaper overall. You're still going to have this limited resource. If you have a bunch more tasks you just throw at these computers, your pipelines are going to have to take longer because, your runner machines can only do so much. And yeah, all of this is just to preface that pipelines are like any other thing in kind of the programming world. If you could cut scope and scope out just what is actually going to bring you benefit, then things are going to go well. It's everything in moderation. With that out of the way, what is the point? Part two. Uh, People will think that CI and CD is a thing you do on big corporate projects because otherwise, it's not so big of a deal to just have, an indie developer ship their game by uploading a Unity build manually. And sure, it's not, but basically, even at any scale, even a very small scale, you can get benefit out of using pipelines to do stuff that is the most annoying for you, the most tedious, and things that are not necessarily huge time costs for you. You don't have to automate everything. Um, but the general idea is that you see this sort of graph here. If you do things manually, you might spend a short time every time, but it's going to add up. If you have a project that goes on for 3 years and you keep releasing updates, the amount of time you've spent just sitting there and dealing with like zipping up files for each platform and uploading them through some web interface to like itch.io or Steam is going to accumulate. Whereas if you automate that earlier on, you spend a while getting the automation to actually work, but unless like the Steam API changes or the way Unity packages things changes or itch.io changes, unless something changes, you don't really need to touch this stuff. You just let it run every time that it's supposed to do something. And so the theory is that you save all of that time over a longer lifespan of any project. Um, and at least as far as big corporate projects that do have huge CI automations, I'll also throw out that there are dedicated roles in a lot of companies that are just for setting up CI pipelines. So it's an entire career path. If you're working on an indie game as a side project or like just kind of to prove out your skills, then CI is a good thing to have on your portfolio. It's a good thing to be aware of because that could transfer well into the more corporate world. Um, so I have a couple examples here, and in these examples, I'm more going to go over the tools first that I'm using. And like I said earlier on, there are tons of tools out there. If I tried to cover how every different tool works, we would be here like for an entire week. And also, I don't know how all of the different tools work because I only use a few of them that fit my use cases. But GitLab CI and CD. So GitLab is primarily a Git version control server offering. And in addition to that basic functionality, they have additional features such as the CI/CD pipelines features. So if in your code base, if you have a file that is labeled as GitLab CI YAML. GitLab will execute that file. It will read it and understand a set of definitions of tasks and execute those to be a little bit more precise. When you push code or on an interval that you can configure, and there's a few other ways to kick off pipelines. But yeah, usually it's all about when people push code is when you really want to go and run tests so people can push code and you see, oh, okay, the unit tests for this character controller or whatever stopped passing once I pushed this change to the gravity. What gives? And maybe you just need to update your tests. Maybe you need to take a look at whether you introduced a bug. Uh, but yeah, the more frequently you can run things, uh, the more benefit you're going to get out. And really, it just helps you pinpoint when things went wrong without having to look over a huge period of time. Anyway, sidetracked a little bit, but GitLab itself supports a few different kind of runners. In the CI/CD world, runners are the actual host machine where that like will reach out to GitLab and say, "Hey, give me jobs to do." Whereas the actual jobs that run within a runner can take several forms based on the type of runner. So a shell runner. This is something that applies also to stuff like Jenkins. You can have a shell runner, which basically the runner is literally just taking a job and saying, okay, I'm going to run whatever commands are associated with this job directly in the shell on the host, which, depending on what you're doing, could be how you want to go. Like if there's certain things you have installed in that system, you have like some kind of long running thing going on, but usually it's a lot of headaches and it's a big security hazard, honestly. So the most common type of runner in most CI setups is Docker-based runners. So on the host machine, you'll have a program that is asking for work to do, and when it gets a task, it will spawn a container, and inside of that container, it will actually run the script for that task. Um, and then, yeah, there's other types, but we're not going to get into those. And so, as far as Docker, it is a container-based virtualization software ecosystem, pretty much. So, very common terms you'll hear are image and container. So, a Docker image is something that is like a static set of data. Uh, and when you create a container from an image, what you're doing is you're kind of setting it in motion. So, like, think of an image as like a Windows 95 install disk and a container as basically all of the state that's associated with once you've actually installed Windows 95 on a machine and you're like sitting there doing something with it. It's running a system that started out from that image. Um, and so Docker's relevance here is that it is really good for CI/CD use cases. So like I said, with shell runners, you can have a bunch of side effects introduced into the host because you'll run one job and maybe it's running shell commands that are literally messing with how the services on that host work, or like installing packages or changing configuration of network or something. You don't know what they're doing unless you wrote them yourself. But even though it's very easy to make mistakes and screw up your actual host. So uh, when you have a Docker-based environment, any kind of job scripts are going to be executed inside of this sort of walled garden. And if they try and do something that would impact the the operating system, like installing packages, that state is virtualized. And when another job starts up, uh, those changes don't carry over. So it's good for establishing that clean, consistent state, which is kind of the whole point. So also, as far as just the amount of Docker images that are available, just straight up online as official Docker images. Um, like there's Python Docker image, there's Rust Docker images, there's one for just about every kind of common developer utility you can imagine, and there's plenty of ways you can mishmash them together without having to really sit there and start from scratch. So that's why I've added this line here that it's very easy to use a different operating system or a different version of a software for many different tasks. So, like if you're building for a bunch of different platforms, instead of having to have like 10 different computers in your house or office that have different versions of Linux, like different distros, if you have one actual machine with Docker installed, then you can very easily build for those 10 different Linux distros or more, uh, because well, that's just the power of virtualization. And then as far as this line about using the same images containers, uh, at least for me, what a very common thing is I will have a workflow where the CI/CD pipeline builds code in a certain way, and the local builds that I will run on my own dev workstation are literally just shell scripts that call Docker and ask Docker to build something the same exact way. So that even locally, I'm still getting that very consistent build. And I know that if something breaks on my system, that it's probably exactly the same way in the pipelines. And that's exactly how something is going to be broken when it gets deployed to itch.io or Steam through these automations. So it helps me to be aware of these things. And then Docker and Docker, you can sort of layer things. So you can have Docker runners that are actually building things inside of like further encapsulation of Docker. So just running builds or running containers without having to have the commands to run Docker be on the host. Um, Nesting. Anyway, so a pipeline basically is a graph, usually, of some kind. There's things that depend on each other. So this is a fairly simple example of like a screenshot of a GitLab page for a pipeline in a game jam recently. And you can see there's this build game job, which is just running a like the actual build for some code. And then this pages job that's highlighted on the right that's depending on it is something that's like producing um, like an actual web deployment based on those files that were generated in the earlier stage. And you can also look at kind of the grayed out things here and see that there's a bunch of other tests that I have set up for that project that just run basic Rust like cargo commands to check, is the code formatted properly? Is it generating compiler warnings? Is it out of date? That kind of thing. A little bit more complicated example. This is for an old Unity game project I made called Connexagons. Um, and this, by the way, to be fully clear, I didn't make this pipeline fully on my own. This is from a place called Game CI, which you can basically just Google. And like that's kind of getting back to the fact that a lot of this stuff you can kind of put together Lego pieces. You don't necessarily have to script everything from scratch on your own. Like I didn't go and say, "Oh, let me figure out how to run license checker and stuff for Unity in a shell script and build this all out." I just took some templates, fit them to my needs, and got them to work. So, like in this case, the downloadable files for this Windows build for this Unity game, before they can be pushed to itch, they are being built for this platform. And before that's happening, the way their pipelines were set up that I use the template, they have to get the Unity version from the project. So that's its own special separate job. Honestly, not quite sure what the ins and outs are, but it works. And I didn't want to spend more time engineering something, like reverse engineering something that just works. And then finally, this example, you're not supposed to necessarily squint at this. It's just you can make very complicated pipelines if you have a need to. So this is for IsoMetro. I've been at this project on like over 2 years now, and I found a ton of little individual tasks that made sense to run in the CI pipelines. And so just whenever something needed to be automated, I threw it in here, and now the result is there's a lot of stuff depending on each other, but that's a lot of stuff I don't have to do every single time an update will roll out. Um, so here's an example of a CI job. And I'm not going to go super in the weeds with these. Like I have this and a slightly more complicated example, but the point of this whole thing is really just to talk about the concept and the benefits of this so you can look more into these on your own. With that said, in the GitLab CI CD syntax, what we have here is we have this Rust warning check job. That's the name of it. The Docker image that it's using is just the official Rust Docker image. We've put it in the test stage, just show it. So it groups with other jobs that are also tests in the UI. It needs nothing, so it starts immediately. It doesn't have to wait on any other jobs. It's not dependent on anything. Then, as far as this variables section, GitLab is just conveniently giving us a way to set these environment variables. So what I wanted here was for cargo check to run with this D warnings environment variable set for Rust flags because it pays attention to that. So not something you really need to remember, but just this is uh, just a very straightforward thing. When you know that like the tool needs a certain environment variable, you just set them up here. The actual script that's being executed in this case is a one-line script. It's just running this cargo check command, which in the case of Rust, if you have compiler errors, cargo check will fail, which will show in the pipelines as like this job failed, and it will prevent that that branch like from being merged into main or anything until you get the pipelines fixed up. So just like it's also a quality control thing. In this case, since I've also added this dash D warnings content to this Rust flags variable, this will fail even on compiler warnings, not just errors. So in my case, I wanted that just to be extra strict about like if there's warnings, we should probably get them sorted out instead of letting the code base just become oops all warnings like most C++ projects do. And as far as a more complex example, so this is just using the Rust image that's official, and it's just taking that right off the shelf and running a command pretty much. But in some cases, you want to install tools your own way, especially if you have a bunch of tools to install, or you need special scripts or configuration that you want to be in this image. Because what you don't want to do is you don't want to have all of your install in this script section. You don't want it to run every time. You just want to be able to build like an image and then use it with kind of a small stub script. So this is also from IsoMetro. This is a Docker file example. So I have this CPP test directory within this builders directory in the codebase. And what I want to do is use Docker to build this. And it's got instructions in it. So this from Alpine says that we're going to start with the official Alpine Linux image. And then this is just installing a bunch of libraries that I need, like OS packages. So like this Clang Extra Tools has code linters and things that I want to be able to run. These other libraries are things that my project needs to link to. in order for the linter to work properly. Um, build base is just more tools. Bash, I mean that's bash. I think y'all probably know what bash is. Um, but if not, it's a shell, which just doesn't come with Alpine by default. So, and then the next thing is after it installs these packages, in order to build this image, it copies in my scripts, it copies in this configuration file, which just has formatting rules for my project, and this workdir just says work in this directory going forward instead of the root directory. Not really important in this case. Um, Pretty much, you think of a Docker file as a recipe. If I hand you a bunch of ingredients and say, make me a C++ test library, then this thing is saying, here's what order you do it in. Um, so in the actual CI pipeline, I want to build this. So I've got this job here, which uses the Docker image. So this is what I was talking about earlier, Docker in Docker. You can use Docker inside of a Docker-based CI environment to build Docker images and to run them. So that's why also we have this service Docker in Docker. So this is like the actual daemon that the commands installed in the Docker image are going to try and reach out to. Um, if you don't have this, then these are just going to say, hey, I don't have a daemon to connect to. Like the daemon is what's actually doing the builds, and this is kind of provided by the runner environment, somewhat more on the host. Um, and then as far as the actual script itself, the reason I've highlighted things in blue here is there's a lot of stuff that doesn't really matter. It's kind of just here because it's like correct, but the ideas are what's in blue. So the first thing we want to do is log in to the CI registry, which is uh, a GitLab feature as well. So GitLab has a Docker registry that is associated with your project, and GitLab also gives us these convenient variables in the environment when scripts are running that say, like, here's the path for your registry. So I don't have to sit here and type out like https gitlab dot whatever slash registry slash whatever my project. Instead, I just use this. Very convenient. So it's logging in to that registry in order to be able to push stuff into it. Then we are building this CPP test uh, directory, and that's going to use the Docker file within it to actually figure out what the instructions are to do, and then it's going to push it to this location in this registry. So CI registry image, CPP test, and I also just tag these by the pipeline ID so that they don't get like mixed up. I can tell very easily looking at the Docker registry which pipeline built something. And if multiple pipelines run at once, then they don't overwrite each other in the registry. They're just separate. Um, so yeah, this is just building these instructions. It's going to execute these and push the resulting just image as like a big blob into this registry. And I've also just got some cache lines in here so that this doesn't run unless something has actually changed in this Docker file or in the files that it's referring to. So that's all these caches are for. If you didn't have this, then this would execute every time, but the caching just, I mean, you probably already get what the point of caching is. So as far as actually using this to run the tool in it once it's built, um, a later job in that pipeline, which, as you can see here, depends on the first job that actually builds this image, will use this image. So you could just use this that we push to very directly as saying, hey, GitLab, run this next thing inside of this image from here. And you can use variables like this, and GitLab is very happy with that. And then in this image, all I'm doing is I'm setting another environment variable to something that I just want in order to control how this tool is going to work. and I run this script, which is one of the scripts that came in from here. So this is just copied in, and by this point it's in the image, and we are in the perspective of the image. So if I run this script as the command, then that's just going to execute whatever was in there that was copied in, which in this case is just a C++ linter tool that will spit out some errors if my code is badly formatted, which happens from many time to time. And then as far as examples, I've kind of blasted through them, so happy to jump back through these in the Q&A section. But there's one last example, which is just not even necessarily part of GitLab CI/CD the way I use it, but I thought it was still kind of an honorable mention, which is in your GitLab project settings, and this is true with many other uh, like source control offerings, and it's also you could do this in a CI job. You could like use a webhook more directly with a shell script, but I've got this configured in like IsoMetro. We have a Discord where the devs are. We've got this GitLab activity channel, and whenever some event happens, these messages show up saying like, "Hey, someone merged a merge request," which is good to know because if a bug was introduced, this is when you want to start watching for that. It says who pushed to where, what was pushed. You can see in this message it's saying that a pipeline that ran on main has passed with warnings. So maybe like my Rust dependencies are out of date or something. You can have pipelines that will outright fail, or you can have them pass completely, or you can have them pass with warnings. So like jobs that are marked with an allow failure flag will result in this. But the point of this slide here is just um, things that aren't necessarily always thought of CI and CD. You can still kind of see like there's the same goal is here, even when it's like, oh, you set up an integration in some other settings page in GitLab. Um, so yeah, I guess that concludes the stuff I wanted to go through. Sean or Brooke, what do we do next?
Definitely covered a lot of ground here, and I think that this is really like practical and applicable, especially for me. So I'm lucky to have Ben on my team who handles this stuff. What we do next is we open the floor to questions. So if anyone has any questions for Seth, please feel free to drop them in the chat. And while we wait for any questions that may come in, if I can give you the first one, do you have uh, any additional resources that you use in order to learn more about this topic?
So I'll drop Game CI a link to this in the chat because I feel like this is the most relevant uh, for Unity people here. It's very common use case of everything. As far as like resources for just kind of general learning, the actual GitLab uh, CI/CD documentation is really good. Um, well, I mean, okay, as long as you can get past the marketing crap in Google. Here, this is a better link. The real docs. But other than that, like a lot of at least how I learned about CI/CD pipelines in GitLab or otherwise was pretty much from uh, well, first job I worked at, I got put on a lot of CI/CD stuff as an intern, and then also just personal projects. Like if you don't know how something works, scour Stack Overflow for it. If it seems like it should be simple, there's a good chance that it is. If you think, it's really easy to run this thing on my own computer. Why can't I get this to work in the pipelines? Just go try it. And if you encounter issues, go ask someone. I'm always happy to answer questions about at least GitLab specifically. Um, Go ask on forums. Hopefully that answers you at least somewhat.
Yeah, absolutely. Thank you. Give me a second to see if we have any questions coming in from chat.
Yeah, I'm just watching the text chat. So if I understand correctly, CI/CD takes care of tedious tasks, one of those being unit testing. Can you give a practical example of a unit test on a game script or any of the tasks it can take care of? So I will say, in the case of a lot of games, like what you'll make in Unity, where there's a lot of physics involved, unit testing is not something that's immediately obvious a lot of times. Because you go, well, this is physics based. The physics engine is never going to come up with, the exact same numbers for two different runs of this thing. Or you think, how do I test this without having to sit there and set up like physics triggers to detect whether something went over in a certain area or whatever. Um, but basically, if you even with physics-based stuff, you can set up tests for a lot of things. You just need to think about like what is the simplest case that proves there is or is not a bug that I want to look for. And a lot of times when you do come up with unit tests, whether they're in this context or not, it's pretty much common practice, and not necessarily best practice, but definitely common practice that you don't write extensive unit tests for things until you have a bug and you go, I don't want this bug to happen again in the future. So you write a test case for a particular bug. In my case, where I'm heavily use unit testing is since I'm making a city builder game, there are discrete sort of things that I can test in the simulation. So, like in a tile based world, if I have a pathfinding algorithm that, given a certain budget of how far people are allowed to travel, and given a certain set of things that are on these tiles, I can reliably say, well, I should always get this result that these tiles are accessible, um, and that these other ones are not. That's usually where it would come in for me is if there's something kind of very like algorithm heavy, then I try and put a unit test as far at a minimal scope around whatever I'm trying to test. If there's something that's like testing the economics engine that uses that, and I don't really care about the economics, I don't want to write a test that involves anything outside. Um, Hopefully that sort of answered what you're going for. Uh, to be honest, some of why I don't have good examples for physics-based games is I just don't really have any projects recently that I've worked on that are physics-based. But I guess if it's like you wanted to test that something gets destroyed, like in fragments into pieces, you could check if things are hitting the ground. Or, I don't know, things like that. I guess if you do have a very specific thing you want to test, always just feel free to catch up with me, and I might have an idea on that. Um, so I'll go ahead and move on to the next question. Do you need an extra Unity license in order to run CI/CD actions? That is a super good question. Uh, what I have found is that you don't, as long uh, as you are using the free features of Unity. So like if you're using um like the one that you get under 100,000 revenue and whatever, then you just reuse your license in the CI/CD pipeline. You still do need to set that up so that the CI/CD uh, instance of Unity that'll run inside of a container is aware that it's licensed. But if it's aware that it has the free license, then you basically have infinite seats with that within reason. If you have Unity Pro licenses, then that may be more of a can of worms because if they're sitting there saying, well, how many people are using your project? And you have 5 seats, maybe you have to buy an extra seat for the CI runner and then make sure the jobs don't run at the same time so that the license is never being used simultaneously. I mean, this is a problem I haven't had to deal with, but I just, from what I remember hearing a while back when I was curious about it as well, it's a little bit more dicey. Um, but that's something where if you do need to investigate things like that, you can always reach out to Unity themselves and say, hey, I'm running in a CI and CD environment. Uh, how does licensing work? And I don't know, you may be able to get some technical support uh, or otherwise, because they want your business. They want, and they especially if you say you're running in a CI/CD environment, they're probably going to take you quite seriously because this is something that projects tend to have when they are more established, formal. Um, so yeah, not a super clear answer for you. Sorry. Let's see. How long would it take someone to set up CI/CD for the first time? So I think it always depends on what you're trying to set up. Um, and also if you're familiar with the platform you're on, I guess okay, so truly the first time, like if you've never even been exposed to this before, it'd probably take some amount of time for you to figure out how to follow for example, the game CI tutorials, even using their templates. It's not, trivial, but at the same time, if you're not trying to do something crazy, reinvent the wheel, or come up with the most exhaustive testing setup that does like 900 different scanning tools against your code or whatever, it's not the end of the world. And in the case of some very common projects, GitLab actually has their own templates. So like you can go in your project and set up I think there's an automatic CI/CD thing. It's been a while since I looked at that. I don't use it, but I know there's like a button when you have a project that doesn't have a CI file in it, they'll try and tell you like, hey, you can click this button and it'll automatically guess what your project is. Um, yeah, I guess just you can always try it. You can always try setting up CI stuff for your project, and if you realize you're taking too long, stop and try it another day or don't. Like, just try not to get stuck. It's like any other engineering thing. Just see if you can do stuff in moderation. Uh, anyway, so as far as what is the cost of running CI CD on GitHub and GitLab, I don't know about GitHub. I just know they have GitHub Actions, and I've heard people do like that as well. As far as GitLab, the cost varies depending on your like infrastructure. But I'll tell you this, in my case, for IsoMetro, the cost of GitLab, at least so far, has been zero because I've been able to get away with using the free software as a service offering of GitLab, which I feel like with how much like stuff I spam through in terms of pipelines and how much storage I use, I'm sure at some point they're gonna correct that. But at least for now, GitLab, the platform, hasn't cost me anything for this project. However, as far as runners go, that's usually where you'll run into your tangible expenses the soonest. So if you use even with the free GitLab offering, they do throw in, I think it's 400 minutes of CI and CD compute time, which if you don't have much going on is actually, totally enough to do common build or test tasks. But when you're running as many as many jobs in a pipeline as I am for IsoMetro, you will run out of 400 minutes very, very, very fast. So you can pay for more minutes directly, which, that's just, I mean, that's software as a service for you. Or you can buy a like higher tier subscription than the free edition of GitLab, which again, software as a service. Or what I do, which in my opinion is the most cost effective, at least at my scale, is I have two very small form factor Dell Optiplex machines that were refurbished that I bought at Micro Center, and both of them are running Linux. They have Docker installed, and they have the GitLab runner installed, which is open source software. And when they're just sitting there, they're periodically checking GitLab through their own protocol, like GitLab designed this. They're checking GitLab for work to do, and they will try to execute that work. And if they go down, I mean, the consequence is just my pipelines don't run, and I get very sad. But uh, those machines are pretty cheap. I think like all in all, there's no way I've broken $1,000 with any GitLab runner I've ever bought, including before these. There's one exception, which is I have a Mac Mini as well, which is used for running Mac OS build jobs because Apple is special. Um, that honestly waste of money. Just don't support Apple products. Anyway, as far as most use cases, if you can run it in a Linux uh, shell script, you can run it for cheap on the cloud or at home without having to sit there and worry about like, you know, I mean, the consequence of not having enough runners or not having fast enough runners is just your stuff runs slowly. Unless it runs out of memory, but then you just limit the jobs that can run all at the same time, and usually that's fine. And again, you're just back at, oh, it's slow. Let's see. Okay, I don't see any more questions. Anybody got anything else? Or, yeah, if I didn't necessarily address your question too well, you want to kind of narrow in on what I can ramble more about, feel free to.
All right. Seems like the chat's quieted out. So maybe what we can do is we can go ahead and move to the meetup portion in the general VC, and then if anyone has any additional questions or follow up, I don't know. Actually, I'm assuming Seth, are you going to be joining us down there?
Sure.
Yeah. So if anyone has any additional questions or follow up, maybe we can just kind of continue discussion down there, or just move into kind of a more general discussion. But that said, again, thank you so much, Seth, for this presentation. This has been great. And I will see everyone down in the general VC.
Thanks, y'all.